11th century, people thought about light and vision like a giant puzzle. Lots of guesses, but not many pieces that actually fit together. Ancient Greek philosophers, they argued whether beams shot out of our eyes or streamed in from objects, but almost nobody stopped to ask, hey, can we actually this? Ibn al-Haytham shows up right at this turning point in history. Imagine cities like Baghdad and Cairo buzzing with scholars, debates, and libraries bursting with ancient texts. Science wasn't just about collecting facts anymore. People started questioning old ideas, arguing with the classics, and most importantly, putting everything to the test. This shift? It's huge. For the first time, observation and experimentation matter more than tradition. If Aristotle said something, great, but could you prove it yourself? Ibn al-Haytham had a unique edge. He wasn't just a mathematician, or just an astronomer, or just a doctor. He dabbled in all of it, and that broad training let him see things differently. Instead of treating light as some mystical force, he asked, what if I treat it like a real physical thing? What if I can actually measure and experiment with it? That was radical. He designed experiments, used dark rooms and pinholes, and showed that light travels in straight lines. He even figured out how vision really works. Light reflects off objects and enters our eyes, not the other way around. Ibn al-Haytham didn't just answer old questions. He changed how science itself was done. He helped launch a whole new way of thinking, where testing ideas matters just as much as having them, and really that's the spark that lit up the future of science.
Welcome to For Science Salah Lotfi channel, where global scientific research becomes clear and accessible.
هنا نحول الأبحاث العلمية العالمية إلى معرفة مبسطة مترجمة لك بلغتك.
Ici, la science est expliquée et traduite pour tous. Ciencia clara, accesible y disponible en varios idiomas.
Wissenschaft, verständlich und mehrsprachig für jeden.
قناة For Science صالة لطفي channel. العلم للجميع وبجميع اللغات. تابعنا لاكتشاف المزيد.
For centuries, people believed something that sounds downright strange today. They thought vision happened because your eyes sent out rays, beams that reached out and touched whatever you were looking at. Seems logical, right? But here's the wild part. Nobody had actually tested if that was true. Enter Ibn al-Haytham. He asked a question that on the surface sounds almost too simple. Are our eyes sending out light, or is light actually coming into our eyes? It's a tiny shift in perspective, but it changed everything. This wasn't just a new question, it was a scientific revolution, because when you frame the question this way, you can't just accept what some old book says. You have to experiment, you have to observe. And suddenly, vision isn't just a mystical process, it's a phenomenon that follows rules. Rules we can uncover, challenge, and refine. By treating vision as a physical process, Ibn al-Haytham pushed the boundaries of what science could be. He was one of the first to insist that our understanding of the world must be rooted in observation and experimentation, not just tradition. That single radical question, it didn't just change how we think about seeing, it forced us to rethink how we study light itself, and in doing so, it laid the groundwork for the entire field of optics. Sometimes, all it takes is asking the right question to turn the world upside down. If you enjoyed this journey into the history of science, make sure to subscribe to For Science Salah Lotfi channel for more fascinating stories and discoveries.
If your science only fits in one box, you're missing the bigger picture. The world isn't divided into neat categories, and neither is true discovery. Throughout history, the greatest minds have always looked beyond the boundaries of a single field, searching for connections that others might overlook. Science thrives when curiosity is allowed to wander, when ideas from different disciplines collide and spark something new. This is where innovation is born, at the crossroads of knowledge. Ibn al-Haytham proved that real discovery happens when you mix things up. Living in the golden age of Islamic science, he wasn't content to just read about the world. He wanted to understand it, to test it, to see how everything fit together. He experimented with water clocks, astronomy, engineering, and most famously, optics. His approach was revolutionary. He believed that to truly understand something, you had to observe, question, and experiment, not just accept what others had written before. He used geometry to trace light rays, math to measure angles, physics to explain reflection, and even physiology to understand the eye itself. Ibn al-Haytham's experiments with light and vision laid the groundwork for the modern science of optics. He realized that vision happens when light travels from an object to the eye, not the other way around. A radical idea for his time. By combining careful observation with mathematical reasoning, he was able to explain how lenses bend light, how images are formed, and why we see the world the way we do. By connecting all these ideas, he built a scientific framework far ahead of his time, and showed us that big questions need more than one kind of answer. Ibn al-Haytham's legacy is a reminder that the most profound discoveries often come from blending different ways of thinking. His work didn't just change how we see light, it changed how we see knowledge itself. To solve the mysteries of the universe, we must be willing to cross boundaries, ask new questions, and let curiosity lead the way.
Alright, let's talk about one of the biggest breakthroughs in the history of science. Imagine living in a world where people believe that your eyes shoot out rays, like tiny flashlights, to see the world around you. Sounds wild, right? Well, for centuries, that's how people thought vision worked. Enter Ibn al-Haytham, the genius who turned that idea on its head. His most important conclusion was actually pretty simple. Light doesn't come from your eyes. Instead, it travels from external sources, bounces off objects, and then enters your eyes. You're not casting out rays, you're catching them. Vision, he realized, is a passive process. You receive light, you don't emit it. This might sound obvious now, but back then, it was revolutionary. It changed everything. For the first time, light could be studied as something independent from how we see it. This separated physics, the study of the world, from psychology, how our minds interpret it. And, most importantly, it set the stage for real experimentation. In his legendary book of optics, Ibn al-Haytham didn't just guess at how things worked, he analyzed reflection, refraction, shadows, lenses, and image formation using systematic investigation and controlled experiments. No more just hand-waving or speculation. He wanted proof, evidence, repeatable results. This was the birth of experimental optics. Every time you look through a lens, glance at a rainbow, or snap a photo with your phone, you're benefiting from the scientific approach he pioneered over 1,000 years ago. Ibn al-Haytham didn't just explain how we see, he taught us how to look for answers. And that, to me, is true genius. If you enjoyed this video and want to learn more about the wonders of science, don't forget to subscribe to the For Science Salah Lotfi channel. Alright, let's talk about what really set Ibn al-Haytham apart in the world of science. It wasn't just the answers he found, it was the way he found them. Imagine this, 1,000 years ago, when most people relied on ancient books or pure logic, Ibn al-Haytham decided that wasn't enough. He wanted to see things for himself. So what did he do? He designed experiments, real, hands-on, repeatable tests. He didn't just trust what others had written. He closed himself up in dark rooms, carefully controlling every bit of light. He'd use screens, apertures, basically little holes, and reflective surfaces, all to see how light behaved. One of his coolest setups was basically the ancestor of the camera. He'd take a dark chamber, think a big box or even a whole room, and poke a tiny hole in one wall. Then, he'd let sunlight stream through that opening. Guess what happened? An inverted image of the outside world would appear on the opposite wall. It must have looked like magic, but for Ibn al-Haytham, it was a way to test how light travels in straight lines. And here's the thing. This wasn't just a neat trick or an accidental discovery. He was running a real experiment, controlling the variables, checking the results, and asking, does this always happen? If it did, he knew he was onto something real. For Ibn al-Haytham, instruments were game changers. Tools weren't just nice to have, they were essential. He knew that to discover the truth, you had to test, measure, and repeat. If you wanted to understand light, you didn't just think about it. You built something. You observed. You experimented. That's the spirit that totally revolutionized science. This idea that you could use experiments and instruments to dig deeper, to figure out what's really going on in the world. So, next time you're in the lab, fiddling with equipment or setting up an experiment, just remember, you're following in some seriously legendary footsteps. Ibn al-Haytham turned curiosity into a method, and that method changed science forever. And honestly, that's pretty awesome. Let me take you back to a time before telescopes, before cameras, before we could even imagine lasers or fiber optics. Picture the 11th century, when Ibn al-Haytham, a brilliant thinker from the Islamic Golden Age, was hard at work. Now, Ibn al-Haytham didn't invent the camera, or the microscope, or any modern optical gadget. But honestly, what he did was even more pivotal. He figured out the rules, the basic principles that make all these devices possible. Take controlled light environments. He realized that to truly understand how light behaves, you need to control its environment. You need a dark room, a single tiny opening. That's how he showed how images form through apertures, laying the groundwork for everything from pinhole cameras to modern digital sensors. But here's where he really changed the game. Ibn al-Haytham wasn't just guessing or watching sunlight through a window, he believed in testing. Over and over, he set up careful experiments to see what light actually did. He made experimentation itself a tool, a scientific instrument. That might sound obvious to us now, but back then, it was revolutionary. Because of his systematic approach, later scientists could build on his work. They developed optical labs, new imaging systems, and eventually, the photonics that run our fiber optic networks today. Modern instruments didn't just pop into existence. They evolved step by step from the principles Ibn al-Haytham put to the test 1,000 years ago. So next time you snap a photo or look through a microscope, remember, you're not just using a device. You're holding the legacy of a man who saw the world differently and taught us to see it too. If you enjoyed this journey through science and history, don't forget to subscribe to the For Science Salah Lotfi channel for more fascinating stories and discoveries. Ibn al-Haytham was more than a brilliant mind. He was a bridge, connecting worlds and centuries through his relentless pursuit of knowledge. His groundbreaking work on optics and the scientific method didn't just echo through the halls of Baghdad, it traveled far and wide, crossing borders and languages. When his books were translated into Latin, they found new life in Europe's universities, sparking curiosity and debate among scholars eager for discovery. There, hungry minds like Roger Bacon and Johannes Kepler picked up where he left off, sometimes agreeing, sometimes arguing, always building on his foundation and pushing the boundaries of what was known. Think about Kepler's famous breakthrough, explaining how our eyes form images on the retina, a discovery that changed our understanding of vision forever. That leap, totally impossible without al-Haytham's earlier groundwork on how light interacts with the eye, and his insistence on careful observation and experiment. But here's the best part. This wasn't simple copy-paste science or mindless repetition. This was a relay race across centuries and cultures. Every thinker took the baton, ran a little farther, and handed it off again, each adding their own insights and questions. It's easy to imagine ancient scholars working in isolation, lost in their own worlds of parchment and ink. But the reality? Science thrives on connections, on the sharing of ideas, and the spark of collaboration. Through translation and debate, al-Haytham's ideas became part of a global conversation, one that still shapes how I understand the world today, and how we all see it. So, the next time you look through a camera, read about the speed of light, or even blink, remember, you're seeing the world through a lens first shaped 1,000 years ago, by minds reaching across time. That's the power of scientific continuity. And it all started with curiosity, experiment, and the courage to share ideas with the world.
Alright, let's set the record straight about Ibn al-Haytham and the so-called invention of the camera. You've probably heard it somewhere, maybe in class, maybe online, that al-Haytham invented the camera. Sounds cool, right? But honestly, it's not really true. What al-Haytham actually did was way more important than just building a gadget. He invented a method, a way of thinking that still shapes science today. Yeah, he experimented with the camera obscura, that dark room with a tiny hole projecting images. But his real breakthrough wasn't the hardware. It was his approach. He insisted that claims about the natural world needed to be tested, carefully and repeatedly, not just believed because someone famous said so. He designed clever experiments, observed what happened, and then let the evidence guide him. In other words, he believed that our eyes, our instruments, and our curiosity could uncover the truth, even if it meant challenging the biggest authorities of his day. So no, al-Haytham didn't invent the camera as we know it, but he did give us something even more powerful, the idea that science is about questioning, testing, and discovering for ourselves. Mixing up these two things, method and invention, doesn't just blur the past, it distorts what science is really about. If I only remember al-Haytham for a camera, I miss out on the truly revolutionary part. His commitment to observation over authority, and evidence over assumption. So next time someone tosses out that camera myth, you'll know the real story. It's not about who made what gadget first. It's about who taught us how to see, question, and understand our world. Thanks for watching, and keep questioning. Ibn al-Haytham. Just saying his name feels like unlocking a secret door in science history. A door that leads to a world where curiosity and reason changed everything. Before him, optics was mostly guesswork. People believed what seemed obvious and rarely questioned it. Theories about vision and light were based on tradition, not on proof. But Ibn al-Haytham flipped the script. He insisted, don't just accept claims, test them. He challenged centuries of assumptions and demanded evidence. With careful experiments, precise measurements, and a healthy dose of skepticism, he showed that light travels in straight lines, and that vision happens when light bounces off objects and enters our eyes. He even built dark rooms, early camera obscuras, to prove his ideas. No magic, no assumptions, just evidence. He made observation and experimentation the foundation of science. What's truly wild? His legacy isn't just about a single invention or a famous book. It's about a mindset, a way of thinking that values proof over tradition. He basically turned how do we know into let's find out for ourselves. He inspired generations to question, to test, and to discover. The idea that to understand nature, you need instruments, data, and repeatable results, that's the real revolution. It's the birth of the scientific method, and that spark didn't stop with optics. It spread to every corner of science. In the next episode, I'll show you how this same experimental spirit changed the world of chemistry, opening up new frontiers. We'll dive into the work of Jabir ibn Hayyan, a pioneer who blended chemistry, physics, and engineering, using experimental tools and hands-on analysis to unravel the mysteries of matter itself. So, stay curious, because the journey from light to laboratory is just getting started, and there's so much more to discover. If you enjoyed this episode, don't forget to subscribe to the For Science Salah Lotfi channel for more fascinating stories from the world of science. And we'd love to hear from you. Leave a comment below and share your thoughts or questions about Ibn al-Haytham and the scientific method. What inspires you most about his story? Let's start a conversation.